Hi. Chances are you have seen tables like this that conveniently summarizes large data so that your audience can understand your data and your main points quickly. Would you believe me if this table here was created with just a click of a mouse in SPSS? Yes. There are many ways to create tables, such as using Microsoft Word or Excel, where you may have to manually draw the table and enter numbers, which can be inconvenient and time-consuming. Well, using SPSS, you have the ability to not only calculate summary statistics instantly, but also automatically generate an APA or other professionally formatted table like this at the same time, which can save a lot of time. Hi, I'm Dr. J from Modern Statistics. Today, I'll demonstrate 6 different ways to summarize your data using tables in SPSS. After watching the video, if you find the tutorial helpful, subscribing to this channel will help me create more contents for helping researchers and busy working professionals like you take fuller advantage of powerful statistical software such as SPSS so that you can complete your tasks more easily, more quickly, and more effectively. Let's jump right in. The first method I will use is the frequency table, and the second method is using the DESCRIPTIVES function. The third method is using the explore function. The fourth method is using custom tables function. The fifth method is using the means function. And lastly, I'll use the cross-tabulation function as the sixth method. For each method, I'll describe its unique purpose and a potential drawback so that you can decide which method is most ideal for your own task. First, the frequency option. Here I am with a dataset that contains 3 variables: gender, minority, and education. Let's see how each variable is coded. Let's go to variable view by clicking here. For each variable, let's look at the values column. Click on the right side of the column. Variable gender is coded 0 for female and 1 for male. Variable minority is coded 1 for yes if the person is a minority in terms of race, and 0 for no. And for education, a person with a less than a bachelor's degree is coded 1, someone with a bachelor's degree is coded 2, and somebody beyond a bachelor's degree is coded 3. Now let's say that you are interested in seeing the count and percentage distribution by gender, minority, and education credentials. Then we'll go to Analyze, go to Descriptive Statistics, and choose Frequencies. Highlight the 3 variables and move them over. And make sure that the Display Frequency table box is checked right here. And if you want the table to be formatted according to APA style, check this box which says Create APA Style Tables. Now, if you want to add more statistical information in your output, you can click the Statistics button here. And for example, we can check mean and minimum and maximum values in the data, and maybe we'll add a standard deviation. Now, 2 variables, the gender and minority, are binary variables with only 2 values, so we're not terribly enthusiastic about calculating standard deviation or even mean values for those 2 variables. But if we want to see them for the education variable, you can check them. We'll click Continue, and we'll click OK. Now, looking at the output, it first shows the statistics table, which we asked for, and shows mean, standard deviation, minimum, and maximum value for each variable. And then it shows the frequency and percent distribution for each variable separately. It shows that 56% of the sample were male, and 34% were minority, and 60% of the people in the data had at least a bachelor's degree. Now, this is all good information, but what if we want to generate a single table that shows the distribution of education levels broken down by gender? The frequency function alone does not have the capability to produce results by layers, so what do? We go to Data, we go to Split File. Now, we'll highlight gender, we'll click Compare Groups, and then click the arrow button and click OK. And then we'll run the frequency again for education. So we go to Analyze, Descriptive Statistics, Frequencies, and this time we don't need that. And we'll take it out and we'll run highest education completed and click OK. Now, the output shows the distribution of education credentials breakouts by gender now. In this table, we see that the bigger portion of females has less than a bachelor's degree, about 30% compared to males. Now, if you want to break it down further by both gender and minority combined, then we go to Data again, go to Split File, and add minority, then click OK. And we run the frequency distribution for education again. We go to Analyze, go to Descriptive Statistics, go to Frequencies, and we don't have to do anything. Click OK. Then the output shows the distribution of education credentials breakouts within minority values, which is further broken down by gender. Now, one thing you don't want to do when creating a summary table like this is to choose variables with too many categories, like beyond 4 or 5 categories, because it quickly becomes overwhelming for your viewer to comprehend all the numbers shown in a single table. As convenient and quick as this frequency function is, it has two major drawbacks in my experience. Number one, rather than generating the table in one step, you have to go to a data and select file each time you want to generate a table like this, okay, which requires a few extra steps. Number two, we saw earlier that the distribution of education appears to be different by gender. But does that mean there is a statistically significant difference in the distribution of education by gender? Is there a gender impact on being able to earn education credentials? Well, to answer the question, we will need to do a chi-square test, which isn't embedded in the frequency function. Method number 2, the descriptives option. The descriptives option works in many ways similar to the first method, the frequencies option. We go to Analyze, go to Descriptive Statistics, go to, this time, Descriptives. Highlight the 3 variables, move them over like so, click on the Options button, and here in the Descriptives options window, we see many of the statistical options that were available in the frequencies function. Notice this descriptives function does not calculate counts or percent distribution. That's right, this function is mainly for scale variables, for continuous variables. So if you have a nominal variable such as gender or minority status, where calculation of mean or standard deviation is useless, then you need to use frequencies function instead of descriptives function. By the way, notice at the bottom right corner of the data set, right here, where it says split by gender and minority. So if you are doing other analysis where you are not interested in looking at distribution broken down by gender and minority, then you must go back to the data and split file function and reset it so that subsequent analysis is not ruined by it. So go to data, go to split file, click reset, and click OK. Then the filtering by gender and minority is removed and we are back to the original data set. Now go back to Analyze, go to Descriptive Statistics, go to Descriptives, and then move the 3 variables like so. Go to Options button, we'll just leave it as it is, and click OK. Now, as you can see in the output, it's very similar to the frequency table, only this time the statistical information is presented horizontally instead of vertically. And if you want the distribution broken down by gender or minority or both, you would use the same routine, that is to use split file function as before. So go to Data, Split File, click Compare Groups, Gender, bring it over and click OK. And then go to Analyze, go to Descriptive Statistics, Descriptives, and run the same information again and click OK. Now, there we have pretty much the same information minus the frequency table. Method number 3, the Explorer option. Here we are back to the data set. For the Explore function, go to Analyze, go to Descriptive Statistics, and select Explore. It has a nice user interface in that SPSS already assumes that you are exploring some kind of relationship between an independent variable and a dependent variable. If we are interested in seeing whether earning education credentials depends on the person's gender or minority status, then we can consider the education to be on the dependent list. So move that over and move the two factors, gender and minority status, or we usually call this our independent variables, and move these to the factor list. And since we're focusing only on the statistics using tables in this tutorial, we'll check only the statistics on display. But it's good to know that we have the option to generate the summary report using both tables and plots. If you're interested in learning the many ways to visually describe the data in SPSS, please make sure that you subscribe to our channel and check the notification button so that you don't miss it in our next video. Now, if you click on the statistics button, it calculates the 95% confidence interval for the mean, which means that if the average education level among the participants in this sample was say a score of 2, but you want to know in the population the range within which the mean would vary, then this confidence interval gives you a good estimate. In layman's term, if we were to draw the sample 100 times, then it will let us know that 95% of the time what the range will be within which we can expect the mean to fall. So, and when describing data, it goes without saying how important it is that we check for potential outliers in the data that can wrongly skew our findings. So, if you check the box for outliers, it will give us two different estimates. One result with the outliers included in your analysis, and a second result with the outliers removed in the analysis, so that you can get a more accurate result. Click Continue and click OK. The output starts out with the case processing summary and shows the distribution of the sample by gender. And in the descriptives table, it shows you pretty much all the descriptive statistics for each category. Notice, for example, for female, the mean education level was 2.06, and after removing or trimming outliers that fall outside of the 95% of the sample, the mean education level slightly increases to 2.7. And in the table below it, which says extreme values, it lists the cases in the dataset that were identified as having extreme values either too high or too low. And you'll see the same table for the breakout by minority. Overall, the nicest feature about the Explore function is that you can generate a 95% confidence interval, and that you can calculate the bivariate statistics like we did here by calculating education statistics and see it broken down by another variable, for example, minority here. Still, I see two issues here in terms of inconvenience. If you want the statistics to be broken down by more than one category, right now we did it by only one category, one for minority and the other by gender. But if you want it broken down by more than one category, here SPSS produces two separate tables, but if you want to see it on one table where education credentials are broken down by a combination of both gender and minority, then you'll have to go back and use the split file functioning. Go to data and split file functioning, which, if we can avoid it and have it all done in one step, it'll be more convenient for us. Another drawback is that just like frequency or the descriptives function, it doesn't give us whether the relationship between gender, for example, and education is statistically significant. We'll have to use a chi-square function separately to answer that question. Method number 4, custom tables option. The custom tables option allows you to have a greater flexibility in terms of designing the layout of the table. In the previous 3 functions that I described earlier, we didn't have the ability to locate our variables in specific places in our table. But in custom tables, that changes. For example, to run the procedure, go to Analyze, go to Tables, and go to Custom Tables. And you will see this dialog. Just click OK. And we'll explore the same question as before to be consistent. That is, we want to see the distribution of education levels by gender. So we want to see the distribution of education by gender. To do that, we'll place the gender, the independent variable, on the column side. So move it over. And place the education variable on the rows, where it says rows, put it over here. And you can see the preview of what your table will start to look like. Now again, whenever you design a summary table like this, always, and I have to emphasize this, always put what you consider to be a factor or independent variable on the column size on top, and put a variable that you consider to be your outcome variable or the dependent variable on the left where it says rows. Okay? It's much easier to read and interpret the relationship for your audience. And when you're reporting statistical information, it's customary to put your IV, the independent variable, on the right or on the horizontal axis. We call it x-axis, and place your DV on the left or the vertical axis or the y-axis. Not only that, if you like to add more categories or subtotals, just click on the button on the lower left that says Categories and Totals. Click that. And you can add subtotals and you can add categories if it suits your needs. And we'll get out of there and go to Titles. You can directly write your title, caption, or little memo to be placed on the upper right-hand corner of the table if you like. And if you click on the Test Statistics button, you can ask SPSS to compare column means, okay, and test if there are any statistically significant differences or the relationship between 2 variables, and check the box for display significant values. So identify significant differences, click and check the box for display significant values. Okay, and we'll set the significance level at 0.05, and also in test for chi-square test, check the box for test of independence, the chi-square, and set the significance level at 0.05. Okay, and then click OK. Now, if you look at the output, compared to all the options that we just enabled, the table itself is quite simple. It gives us 2 things basically: counts of education levels by gender, right? And not even percentages, so it's a little inconvenienced there. In the second table, it gives us conveniently the chi-square test result. The significance value is less than 0.05, which is a standard threshold for us to evaluate whether a significant difference in education exists between gender in this example. And since the p-value here, the probability value, is less than 0.05, the difference in education by gender is statistically significantly different by gender. Now, you might be disappointed that it only shows the distribution by gender, but if you want it further broken down by not just gender only, but by gender and minority status as well in one table, all you have to do is go back to Analyze, Tables, Custom Tables, and select, if we go to the tables again, and select the minority status and bring it over to the top of the space where it says columns. Okay. And click OK. And you will see a distribution of education levels by gender, which is also further categorized by minority status. Table method number 5, the means option. Another way to describe the data using tables in SPSS is the means function. The means function is similar to the descriptives and the explorer function in that it treats variables as continuous or scale variables. The name of this function, the means function, speaks for itself. It is about comparing mean values among other things. So if you have a nominal variable like gender or minority status, then one drawback in using this is that it will not generate a frequency table. To run the procedure, go to Analyze, go to Compare Means, and choose Means. Here is the means window, similar to the Explorer user interface where you see the dependent list and independent list. As before, since we're trying to see whether gender or minority status influence education, we'll move the gender to the independent list and education to the dependent list. Now, you see here it says layer 1 of 1. Okay? Now, if we want to see the distribution of education by gender and have that broken down further by minority status at the same time, then you can use the layer function here. So click Next, and on layer 2 of 2, move the minority status here. Okay. Now, if you click on the Options button, you have a long list of statistical information that can be generated. As you can see, the focus on this function is that it assumes the variables are continuous. So a lot of what you see here is about measuring the dispersion of the variables, the measures of central tendencies such as mean and median, and so on. Okay. Now, one especially unique feature that comes with this means function is shown here under Statistics for First Layer. Now, check the box for ANOVA table and ETA. What this will generate for us is similar to the chi-square. It will tell us whether the mean scored in education is statistically different between males and females. And the ETA will tell us the proportion of the total variance in education that is associated with the membership of the different groups by the independent variable. For example, what percent of the difference in education is accounted for by our gender factor in our example. So, okay, click Continue and click OK. Now, let's look at the second table titled Report. The means, counts, and standard deviation of education are provided for both a minority, which is further broken down by the gender factor. More importantly, in the ANOVA table below it, we see that the differences in education means by males and females are statistically significant, with the significance value being less than 0.05. Now, another valuable information can be found in the measures of association table. In other words, whether the differences in education by gender are statistically significant or not, that alone does not tell us the size or the magnitude of the impact that gender has that causes the differences in education level. In layman's terms, what percent of the variation, or more specifically, the differences in education can be explained by the gender factor? Well, if you look at the column ETA squared right here, and you multiply the number you see here by 100, it gives us the proportion of variance of the outcome variable, the education in our example, that is a function of the gender grouping. The ETA squared value shows up right now as 0.000 in our output. Now, SPSS by default shows up to 3 decimals. To see the actual value that might be hidden there, double-click on this table and put your cursor on this number right here. then you see that the actual value is 0.000439. To see this in percentage term, multiply it by 100, then we get 0.04%. So in layman's term, the gender factor explains 0.04% of the differences in mean education. So from a practical standpoint, the impact size is, yes, very small. Conventionally, in the literature, around 1% is interpreted as having a small effect, around 6% is interpreted as having a medium effect, and around 14% or higher are considered having a large effect. Finally, SPSS table method number 6, crosstab option. The name cross-tabulation is no stranger to us. In fact, all the tables that we've been running so far represent some form of cross-tabulation, and it turns out that crosstab's function in SPSS presents the most versatile form of tabling the data. To run this procedure, we'll go to Analyze, go to Descriptive Statistics, and go to Crosstabs. Now, remember what I said earlier about how you should always practice placing what you consider to be your independent variable on the column x-axis, right here, and place what you consider to be your dependent variable on the y-axis, in other words, the rows. So we place gender on the column, and we place education on the rows. Now, if you want this broken down further by minority status, then you can place minority on layer 1 of 1 and click the statistics button. Now, the word flexibility is really an understatement here. If you want to see whether there is a significant relationship or significant differences in one variable's category by another variable's category, then check the box for chi-square. And if you want to examine the relationship between two continuous variables, then you can check for their correlations here. You can also check the box for ETA if you are exploring a relationship between a nominal variable and an interval variable. So for the purpose of demonstration, we'll check these 3 boxes here and click Continue. Now, if you click on this Cells button, here, in addition to frequencies in each category, you can also demand for percentages for each row, column, and or for total percentages. So row, column, and total. Okay, and click Continue. If you want the variables categories to be in certain order, you can click on the Format button and change the order, for example, from ascending to descending, but we'll leave it as it is. And you also have the option to generate the bar chart if you want to display cluster bar chart here. But that's good enough for now, and click OK. Now scroll down and look at the second table titled Education by Gender by Minority Cross-Tabulation. The table shows the distribution of education by gender, which is further broken down by minority. More conveniently, if you scroll down again and look at the chi-square tests, it shows that the differences in education by minority status are statistically significant. And the remaining 2 tables also show statistically significant relationship between education and minority status. So in this video, we examined 6 different ways to describe data using 6 different tabling methods in SPSS. They all serve slightly different purposes, so I hope illustration of these different ways will help you decide which method is most ideal for your needs. Thank you for watching and hope to see you next time.